Hello, welcome to today's show. My name's Arianelia Locklear, and I'm live here today at the University of North Carolina at Pembroke. So today's topic that we'll be talking about on today's show, magnets make messengers more movable. Now, you heard the word magnets. Not talking about those that are on your refrigerator, but magnets that possibly might one day be inside of our bodies. Now, before we get to the magnets and how they're making messengers move, let's talk a little bit about gene therapy. Gene therapy is when you take a normal cell and you replace a missing or distorted gene with the normal gene. Now, why would you do that? This will help eliminate gene disorders over time, the more you keep doing gene therapy. Now that sounds fantastic. Why don't we do it more? Well, there are some drawbacks with gene therapy. Some of the drawbacks are cancer and even death. Now those are huge drawbacks. But that's what happens when gene therapy normal genes doesn't go to the targeted genes they're supposed to go to. Now, how can we help this? Well, remember those magnets I was talking about? Not the kind that goes on your refrigerator. This is what we use to find targeted sites. Now, we can use this for gene therapy, but we can use this for other reasons as well. This is a huge deal in the medical society right now. But how can a magnet target a specific area? Well, behind me is a demonstration. So, in gene therapy, they use nanoparticles. What we will do is that we'll take magnets and wrap it up with nanoparticles. That's what MNP stands for. So, our magnetic particles, they're not waterproof, unfortunately. So we'll have to coat them with a polymer coating. That's the blue line around here. Also, inside of the polymer coating is a drug. Now this drug will help treat the area that we are going to. So how do we find this area? Well, these little Y shapes around the magnetic nanoparticle are called targeting agents. They will help target the specific area that we are supposed to go to. Now, as you see over here, I have a lot of healthy cells, but this one in the middle is not so healthy, and this is where we're trying to go to. So our magnetic nanoparticle over here will target, diagnose this cell, and then use therapy to help correct this cell to be a healthier cell. Now that we know somewhat how it works, let's talk about what researchers have found. Researchers have put human cells inside of a petri dish with fluorescent light. They took the magnetic nanoparticles and also regular nanoparticles and put them in at the same time to see what would happen. Now, my demonstration back there is not really up to scale. The magnetic nanoparticle is way smaller than the cell because it has to get inside of a cell. Now, it has to get inside of this cell really fast. The reason it does is because of the immune system. If it doesn't get into the cell fast, the immune system will attempt to shut it down. Once the magnetic nanoparticle is shut down, it can't really release any medicine. So researchers saw with a fluorescent light that the magnetic nanoparticles got inside of the cell faster than the regular nanoparticles. Since it got into the cell faster, it released more medicine than the regular nanoparticles. That's absolutely fascinating. The more medicine that you can release, the better chance you have of treating what you need to treat. So, what happens if we take the magnetic nanoparticles and directly inject it into, let's say, a tumor? Well, it will all stay inside of the tumor. It will not go outside of the host's body. Because you have to think, let's say this is now a tumor. So we have our tumor. If I have a magnet to help draw my magnetic nanoparticles, and I keep that magnet there, the magnetic particles are going to stay inside of that tumor and dispense all of the drug. We won't have any of the magnetic nanoparticles going outside of that tumor. But if you don't have a magnetic nanoparticle and just a regular nanoparticle, it will go outside of that tumor and then start dispensing that drug where the healthy cells are. And you don't really want that because then you can damage the healthy cells. So, let's just say that maybe we don't want to inject it into a certain location, right there where we need to insert it. What if we inject it into a totally different area and want it to travel where we need it to go? Well, researchers also discovered that the magnetic nanoparticles are great for that. They took a mouse, injected the magnetic nanoparticles inside of its tail, stuck a magnet by the mouse's liver, and all the magnetic nanoparticles went to that magnet. Another demonstration I have for you. Let's just say that this is skin. These are our magnetic nanoparticles. And this is just a magnet that we are going to put on the outside of the body. Here we go. We got our magnet on the outside of the body. Now time for the magnetic nanoparticles. As you can see, we can pull the magnetic nanoparticles wherever we want to pull them. And not only that, the bigger the magnet, you can put more magnetic nanoparticles towards that magnet. So let's say that we have somebody with a brain tumor. Don't want to necessarily put the magnetic nanoparticles injected directly into the brain, but let's just say that we want to put it in the arm or the leg. If we have a big enough magnet, we'll stick it by the person's head, and those magnetic nanoparticles will travel up towards the head and target the specific spot that it needs to go to and release the medicine. Absolutely fascinating. And also, that can save a person a lot of time, a lot of money. Won't necessarily have to be injected inside the brain, but just injected anywhere. So, what does all of this mean? Well, remember those downfalls we're talking about with gene therapy? That can almost eliminate those downfalls of gene therapy and make gene therapy more healthier, make it more realistic. It can also help treat a lot of disorders. But not only treat them, what if we prevent them? That's saving a lot of lives right there. So, our handy dandy magnets, again, not the ones you stick on your refrigerator, can help save the life of possibly a loved one one day or even our own selves. So, with that being said, I'm really looking forward to more breakthroughs with magnetic nanoparticles. If you have any questions, concerns, please feel free to message me and I will get right back to you.